In this video, we're going to take a look at another handful of theorems related to derivatives. So let's jump right in. If f is continuous on a closed interval a to b and differentiable on an open interval a to b, we will suppose that that is true. We'll let that be true. Then if we know that to be true, if the derivative of x is equal to 0 for all the values of x in the open interval, that function f has to be a constant on that closed interval. All right, so let's roll through this. Suppose f is not constant. If f is not constant on that closed interval from a to b, then we know that there exists x1 and x2 such that, so there have to be these values on the interior. There have to be these values that have function values that are different. But then we could apply the mean value theorem. There would be this value of c in that open interval x1 to x2 such that f prime of c is equal to f of x1 minus f of x2 over x2 minus x1 which is not equal to 0. And this is a contradiction. As a corollary to this, if f and g are continuous functions on the closed interval and differentiable on the open interval, if we suppose that f prime, the derivatives are equal, then if their derivatives are equal, there's this constant c such that f is a constant added to g. Right? So the functions f and g, if they have the same derivative on that open interval, those two functions have to differ by a constant. And so to prove this, simply consider f minus g, right? So consider that function, call it h, and then apply the previous theorem. Okay, so if you consider this function h that is equal to f minus g would give you that h prime of x is equal to 0 for all x, so h prime of x would have to be constant, and so then so h would have to be constant, which would imply that f minus g is a constant. So f is equal to g plus c. Right. And that's that. A couple other theorems that we'll just note, we won't go through proofs of. If we let f be differentiable on the interval I, so if we have differentiability on some interval, then if that derivative is greater than 0, it is strictly increasing. The function is strictly increasing. And if our derivative is less than 0, if it's negative, then the function is strictly decreasing on that interval. And then finally, we have an intermediate value theorem for derivatives. And our intermediate value theorem for derivatives, this says if let f be differentiable on that closed interval a to b, and suppose that k is some number between the derivatives at the two endpoints, then it's going to actually, this function achieves a derivative at somewhere in the interior equal to any choice of k between the derivatives at the two endpoints. Right. And so that is our intermediate value theorem for derivatives. All right, we will talk to you in the next video where we look at the inverse function theorem. We will talk to you then.